This is Mariah Jones for Module 2 D&E. For my first word problem, I have said, Sally had 102 beads. She lost 18 of her beads. How many beads did she have left? So for this problem is a separation problem. Here we have our start bubble. We have our change bubble. And we have our result bubble. Now, we know that she started with 102 beads because it tells us Sally had 102 beads. So I'm going to go ahead and put that in my start bubble. 102 beads. Now, whatever number is going to go in this change box is going to change our start number, and that's how we're going to get our result. So it says she lost 18 of her beads. She lost 18 of her beads, so that means that we can't count them with 102 anymore because she doesn't have 102 anymore. She lost 18 of those, so that's going to be the change. Her losing 18 of those beads is our change. Now, to get our result, she had 102 beads. She lost them, so she no longer has them. So we're going to have to take that away from how many she began with. And usually when you hear take away, you think subtraction. So 102, take away 18 of those beads. Now in the first D&E, I used the base 10 blocks to show this. But here we're just going to do the regular subtraction. So we're going to come over. We can't do 8. We can't take away 8 from 2. So we're going to come over and we're going to borrow. Oh, there's nothing to borrow there. So we're going to come over here and we're going to borrow. That turns into 0. That turns into 10. We're going to take away from that. That turns into 9. We're going to bring it on over here. Now, 12 minus 8. We can think in our head. 8, count up. 9, 10, 11, 12. There's 4. And 9 minus 1 is 8. So 84. So 84 is our result. She had 102. She lost 18. Remember, the change is what happens to the starting number. And that change, whatever that number is what changes the starting number into our result. So 102 take away 18 is 84. Now, if we were to do that using a strip diagram, it would look something like this. We have 102 beads. Now we know that she lost 18 of those beads. So, if this little portion here is 18, then we know 18 and whatever this portion is, 18 and this portion together is going to be 102. So we could say 18, this portion, combined or added with this portion, which we don't know, would equal or total 102. Now, in our result bubble a second ago, we figured that 84 was the number that she had left. So 18 and 84 together would make 102. And we could do that over here just to double check. 84 and 18. 8 is 9, 10, 11, and 12. The 2 down here, the 1 up here, 8, 9, and 10, 102. So we were right. Now, we could also say that 84 and 18, see, we're just switching the add-ins there, equals 102. So, when I showed the separation bubbles, we had said that she had 102 beads. take away 18 beads, that would leave us with 84. Now, we flipped our add-ins here. 18 plus 84 is 102. 18 and 84. Let me go ahead and write that in so you can get the visual. And 84 and 18 is 102. So either way, you can flip-flop the add-ins and it's going to give you 102. Now we do 102 take away or minus, because she lost, 18 is 84. Now, we flip-flop these add-ins. Could we flip-flop these add-ins? 18 minus 102. 18 take away 102. You cannot take away or subtract 102 from 18 because 102 is much larger than 18. That would not give us 84. It definitely would not give us 84. So a little trick that I use to remember when talking about addition and subtraction. So, as I was saying, a little trick that I like to use when when I'm using addition and subtraction about the add-ins is that addition, you can switch the add-ins. They both kind of rhyme there. In subtraction you cannot. And then you can again when you get to multiplication, but that's just for addition and subtraction. Addition, add-ins, you can switch them indeed. Now for my next problem, I have used the word problem. There are 10 students in kindergarten. There are 3 boys. How many girls are there? So it tells us there are 10 students in kindergarten. We know that that is our total, that there's 10 all together. So to me, it's given us a whole. That right there is a whole. Next it says 3 are boys. How many are girls? Or how many girls are there? So to me, that's giving us a part of the whole. There's 10 students all together, and it tells us that 3 of them are boys. So now we must find the missing part. And because our total just so happens to be 10, I decided that I'm going to use a 10 frame to figure out this answer. So I'm going to fill up my 10 frame, and I'm going to put a counter for every student. There's 1 student, 2 students, 3 students, 4, 5, 6, 7, 8, 9, and 10 students altogether, 10 kindergartners altogether. Now, the part that it gave us was that there was 3 boys. So I'm going to go ahead and flip over 3 to represent the boys. Now, very easily we can tell that there are 1, 2, and 5. There are 7 girls. If there's 3 boys, the rest of them have to be girls because we have to have 10 all together. So, 7 girls. Now, we can check that. We can put 7 in our brain, and we can count up 8, 9, and 10. 3 there. 7 and 3 is 10. Now, if this were to be used in a strip diagram, it would look pretty much something like this. Except it wouldn't have given us the 7 there. So there's 3. 10 is our total, 3 boys, and this would be our girls. Now we can say 3 plus what equals 10, which we figured that out. That was 3 plus 7 equals 10. And we could flip our add-ins, because we're adding 7 plus 3 equals 10. This is 7, no matter which way we do it. 3 and 7 together is 10, or 7 and 3 together is 10. Now, we could also say that 10 equals 3 plus 7, because the equal sign means that the amount on this side of the equal sign is going to be exactly the same as the amount on this side of the equal sign. So let's try. 10, we have 10 here, is equal to, what is 7 plus 3? 7, 8, 9, and 10. So is 10 equal to 10? Yes, it is.